Hey folks, quick video about acceleration. Acceleration, much like velocity, deals with the change in something. With velocity, we were dealing with a change in something that occurred in a time period. What changes when you're moving or when you're traveling at velocity is your position. At the same time, we're about to start studying acceleration, which is a change in something, a change in a time period. But what changes with acceleration isn't your position, something else changes. It's your speed or your velocity. If you're sitting at a stop sign, say you're you're in a little Volkswagen Bug or something. There's an overhead view, so it might not look much like a car. You're sitting at a stop sign. As you sit there, you're not moving. Time is passing, but your position is not changing. So we'll say that your velocity at that time is 0 miles per hour, 0 meters per second, whatever unit you want to use. For that to change, for you to actually start moving, your velocity has to change. That's what the process of acceleration is the act of changing your velocity. At some time later, after this person completely stops at the stop sign and takes off, if it was a red light, it would turn green and they would start moving. At a later time, they'll be traveling with some velocity. In this case, we could say their velocity might be, 40 meters per second, traveling at some speed. We've noticed that their speed has changed, that their velocity has changed, therefore this car had to accelerate. Now, a change in velocity doesn't happen instantly. I've never seen a car that you can sit in at a stop sign, put your foot down on the gas pedal, and instantly, I mean no time later, instantly be traveling 60 miles per hour, or even 10 miles an hour, or even 2 miles per hour. For every bit of increase in speed that you have, it takes some time for it to happen. So there's always going to be a duration for the change in your velocity. Now the way we calculate this change in velocity, the way we calculate the acceleration is with this equation right here. We're real quickly going to find the acceleration of this car. Since its velocity changed from 0 to 40, we already know it's changed in velocity. But the last thing we also need to know is how long it took, how much time it took, what was the duration of time it took. And for this example, we're going to say it took 10 seconds. The time that it took for this car to accelerate was 10 seconds. The speed or velocity it started at, VI, is 0 meters per second. The final velocity it ended up with, VF, is equal to 40 meters per second. The two things we have to know to find the acceleration are the change in velocity as well as how long it took. We already know how much time it took, the time period. We only have to find the change in velocity. The change in velocity, the change in anything, is the final minus the initial. VF, 40, minus the initial, 0. 40 minus 0 is, of course, 0. That is the change in velocity. To calculate the acceleration, now we can say right here, the acceleration is a change in velocity, which is 40, divided by a time period, 10 seconds. 40 divided by 10 is 4. And the units on this are meters per second, better written as meters per second squared. That's the same way we deal with all accelerations. We find the change in velocity, we find out how much time it takes, and then just a small calculation, we can easily find out what it is. But the important part of this video is to understand what acceleration is. It's not a change in velocity. This is a change in velocity. Acceleration talks about the rate at which the velocity changes. How quickly does the velocity change? How much time is it taking for the velocity to change? It's a rate. Cool. All right. Another video will come up shortly about how to solve some more of these problems. This is a good start, though.